Okay, we're going to take a look at simplifying radicals, which is number 39 on your summer assignment. Once we take a look at a few examples of these, you should be able to do numbers 40 through 44. The first thing you need to recognize is that you need to use the distributive property. And we'll take a look at the square root of 2 times negative square root of 2. That's going to give you a negative product. And root 2 times root 2 is root 4. Then we have the square root of 2 times the square root of 5. That's a positive square root of 10. Now you want to look for anything that you can simplify. So the square root of 4 simplifies to 2. Don't lose your negative sign out front. The square root of 10 has no perfect squares. So then you would be done with that problem. That was real straightforward. Not a lot going on there. Then we take a look at the next example. It's a little bit more complicated. We have 5 times the square root of 6 times the quantity 3 minus square root of 2. Again, we need the distributive property. Sorry about that. So we have 5 times the square root of 6 times 3. Remember here you're allowed to multiply things inside the radicals together or outside the radicals together. So we have a 5 and a 3 sitting on the outside. So 5 times 3 is 15 times the square root of 6. And then we have 5 square root of 6 times the square root of 2. And because the 6 and the 2 are both under the radical symbols, we're allowed to multiply those together. So that gives us a 5 out front times the square root of 12. Now with this problem, you have to take a look and see if there are any perfect squares hiding here. So the factors of 6 are 1 and 6 and 2 and 3. No perfect squares there. So we're just going to hold that the same right out front. But then when you look at the square root of 12 and you think about the factors of 12, 1 and 12, 2 and 6, and 3 and 4, you recognize that 4 is a perfect square. So we're going to rewrite this square root of 12 as the square root of 4 times the square root of 3. So now in the next step, again, this 15 square root of 6 just keeps coming down along the left-hand side. Then here we're going to change this square root of 4 to a 2. So at the tail end we have 5 times 2 times the square root of 3. So in our last step, the 15 square root of 6 follows along with us. Then we do 5 times 2 is 10 times the square root of 3. And then the last thing you want to recognize here is that the square root of 6 and the square root of 3 are not the same values under the square root symbol, so we can't combine any like terms here. That would be the last thing that you could take a look at. But for this problem, we're all done. You should be able to do numbers 40 through 44 now.